that's your if-then statement. Now we can imagine a situation where if the condition is not met, we still want to take some kind of action, and we can do that quite easily. In most programming languages, in fact, it's probably the case that all programming languages have it, that there's the possibility of an else part as well. So if in this example here you've passed the course, then you can register for course B. But if you haven't passed the course, then there might be this other course C which can fit into your timetable instead. And so we can say here if that, if not, well, not if not, but if that, then execute that. Otherwise, go and do that. So that's the syntax in Matlab. We simply use an else there, which we read as otherwise. So we can say here else reg c equals 1. So let's initialize here. Reg b is 0 and reg c is 0. We aren't allowing registrations without checking first. So once the mark A has been checked, then we can decide which course to register that student for. So let's plot down here reg b and reg c. Let's run this. So in this case, the student had passed course A, so we are allowing a registration for course B, but we aren't allowing a registration on course C because registration for course C wasn't happening in the true part of this if check. Alright, let's say the student hadn't passed course A. Then when we run this, you can see that we no longer recommend that the student registers for course B, but that he register for course C instead. So that's the result that we wanted. So much for if-then statements. Now let's look at for loops. Right? It's often the case that we want to run a set of commands many times, and while running those commands repeatedly, we want to keep track of how many times we have done that, and so the for loop allows us to do that. So in Matlab, that's the syntax, the syntax. So that's where we say for, and then we give it a variable name. So this variable is a counter for us. That helps us determine how many times we've run that loop, or what the current index is as we're running through this loop here. So we do read this as a loop. We can see that I must start from a value of 1, and it will execute these statements. So it will execute all the statements between the for and the end here, and then when it reaches the end, it goes back to the start here, and it will check a condition. So it will check, is I now more than the end value here, right? That's the third argument, this 5. So is I greater than that 5? So if it's not greater than 5, it will increment the value of I and then execute those statements again. And once that's done, once it's executed all the statements in this block here, then when it goes up here, again it will check, is I more than 5? If not, it will increment the value. So let's look at that in our code. Let's create a new one, ex04 I suppose. So the initializer close all, clear all CLC, and let's write that for loop here. So for I equals 1 to 5, end. I did say before we mentally substitute the word 2 for the colon. So for I equals 1 up to 5. And then let's just ask for the value of I to be printed on the screen. So let's save this ex04 and run that ex04. We are in the right folder now. So you can see here that I started from 1 and it incremented itself until it got to the value of 5. So in the code, you can see that we haven't incremented I anywhere. We haven't said I equals I plus 1, right? That's because this for loop is implicitly incrementing I over those values until it reaches the value of 5. And once it's done that, then this loop has ended and it will continue with whatever other statements we might have over here. So for instance, if we had some other operations, then those would execute, the rest of the program would basically run. So that's your for loop, and inside this for loop we can execute whatever statements we like. So let's say we were trying to create a vector, let's say x, and we wanted the ith value of x to be equal to, let's say, x squared plus 2. And so let's run that, ex04, so that's run. And well, I see I've replaced this this vector here with this assignment. So let's just change this to a y here and rerun it. So y is 10, that's fine. And then this x here, we've suppressed the output from that. So let's just ask for that value x. And so you can see that set of values. So in this position, I was 1. So 1 squared plus 2 is 3. And then in this position, I was a value of 2. In fact, we should just plot here 1 to 5 and then ask for x. So you can see here I was a value of 2, so 2 squared is 4 plus 2 is 6, 3 squared is 9 plus 2 is 11, and so on. So we've assembled this this vector x, and we've done it element by element like this. So you can see that y is a counter here, so y is used by the for loop as the counter. However, we can also use it as the index in our vector, which we actually haven't seen before. Prior to this, we just regarded these things as sets of numbers, and of course it is a number, it's a variable with a number, so we've used it here as an index, and then we've also used it here as a value. So the value I, or the variable I, there's nothing special about it, even though it's understood to be a counter in this for loop. It's also just a variable with a value behind it, and we can use it in this way. So that's your for loop for executing that particular statement. By the way, we should notice that in the statement here, I equals 1 to 5, we saw that before, right? In an earlier chapter when we were looking at the creation of vectors, we said that the statement 1 to 5 could be used to create a vector, right? A number colon another number would create for us that vector. So we can say here that this is effectively saying there's going to be a vector here. However, this for statement will not create a vector for I. It will run through each value for I in each value in this vector. It will assign sequentially a single value from this vector, assign it to I, and use it inside the set of statements here. So, but the point is, this is the syntax for a vector, and in a similar way that we used the syntax for that vector, we used a third argument in between to increment, to change from the default incrementing by 1 each time. Right? If we use a third argument in between here, then we would increment by that third argument. So we are incrementing in values of 2 here. So the same thing applies here. We can say 1 colon 2 colon 5, which we read as run I from 1 to 5 using increments of 2. And we can see the result of that here. So here we can see the results, and this looks quite strange to us. We can still see 5 elements, which maybe we didn't expect. We thought 1 colon 2 colon 5 is just 3 elements, and in fact it is 3 elements. This this for loop here will only run 3 times. However, in this position we are substituting the values 1, 3, and 5, and so that's the vector Matlab has created here. So you can see in the first, third, and fifth positions, we have substituted the result of that expression, and then we hadn't supplied it with any values for the second and fourth